Welcome back. I will now show you something that is entirely new in ES6, and that's a new data structure called map. And in case that you're wondering, this doesn't have anything to do with actual maps, like you see on Google Maps or something. So let me explain what maps are in ES6. So a very common use of JavaScript objects is to use them as hash maps, which simply means that we map string keys to arbitrary values. And we did that a lot earlier in the course, especially in the basics section, for example in our more simple John objects. Back then we had simple keys like name, age or job, and then mapped values to them, like John, 27 and teacher. Now this is called a hash map, and up until ES6 we had to use objects for that. But now in ES6 we have something better, and that's maps. So a map is a new key value data structure in ES6. And one of the big differences is that in maps we can use anything for the keys. So in objects we are limited to strings, but in maps we can use any kind of primitive value like numbers, strings or booleans, and we can even use functions or objects as keys, which is really cool and really a big deal. Alright, but enough theory, let's actually use this in practice and construct our first map. And we're gonna implement a very simple quiz with only one question, just to show you how maps work. So this is how we create a map. Let's create a variable, and it will be a constant, and I'm just gonna call it question. And we say we want a new map. And that's it. So we just created a new empty map. So let's now add some data to it. And in order to do that, we use the set method. So question.set, and then we set the key. And in this case, I'm first going to use a string so that we can specify the question text in here. So I say question, which is the key, and then the value. And the question is going to be, what is the official name of the latest major JavaScript version? Alright, and that's it. So this is the first key of our new map. So this works a bit like a property in an object, right? So we could have a question property and then assign this string to that property. So that would be similar. But in maps, this is how we define a new key value pair, okay? And so let's now add some answers to this question. So question.set, and now I can use, as I said before, anything in here. It doesn't have to be a string like an object, it can be anything. And so I'm simply going to say 1. So 1 for the first answer. Let's say ES5. Okay. Okay, and another choice is ES6. And let's add another one so that we have multiple choices here. ES 2015. And a fourth one, ES7. Here we go. Okay, and now we also need the correct answer. So let's add that as well. So that's set, and now I say correct. So we're back to using a string as a key here. And the correct answer is, of course, and I hope that you know it, number 3. So this is the official name of the latest JavaScript version. Actually, the major JavaScript version, because ES7 is the most current version, but that's not the one that everybody uses right now. Everyone is rather focusing on ES 2015 at this point. Alright, and what we can also add here is what happens if the answer is true or if it's false. So let's put another key value pair here, and we already used strings as a key. We used numbers, and now let's use a boolean, okay? So if the answer is true, then we want to print to the console correct answer. And if it's the wrong answer, then of course it's false. and then we say wrong, please try again. And so I think that with this, we have everything set up for our question. Let's now load this and take a look at our map here in the console. So question, and here it is. So this is how a map looks like here in the console. Let's open this. And so here we go. Here we have our entries. We can also see the length, and we see that the prototype of this map is of course a map. So this is like, remember, like an array, for example, where the prototype is an array. And so this is a new built-in type in ES6, so a map. And this, of course, if we see the prototype chain is an object, and so on and so forth, right? So just to see how this looks in a console. Now, what if we actually wanted to retrieve data from this map? What we do is the opposite of set, which is get. And so what we do is question.get, and then we simply have to pass in the key. So let's say that we want the question. And let's console.log this. And so we should see the value, and that's it. So what's the official name of the latest major JavaScript version? Okay, and another cool thing that we can do with maps that we can't do with objects is to get the size or the length. So we can say question.size, and it's not length like it's with arrays, but in this case it's size. So let's see, and it gives us 8. So this works. So 1, 2, 3, 4, 5, 6, 7, and 8. So we can set data in our map, and we can also get data. But we can also delete data and check if data is there, or if a certain key is there. So imagine that we wanted to make this question a bit easier, and in order to do that, we would remove one of these choice elements, right? So instead of having 4, we would have only 3. So let's see how that works. So it's actually very simple. So all we say is question.delete and then the key. And in this case, we want to remove the number 4. All right. Let's take a look at it now here in the console. Question. And so yeah, it's not here. So 1, 2, 3, and 4 is gone. Now, what would happen if we would accidentally run this line of code here twice, so delete it twice? Let's duplicate and find out. Actually, nothing happens. Let's check it out again. Question. So since it's not there, nothing happens. But just to be sure, we can use the hath method. So we can say, if question has the key number 4, then in this case, let's delete it. And actually, this should be here. Okay. So we can get, set, delete, and also check if a certain key is in the map. So if there's a key number 4 in the question, then we can delete that element. And if you decide that you want to delete all of the elements at the same time, then there's also a method for you, and that one is called clear. So let's finally clear everything from our map. So all we have to do is to use clear. So if we now load this and then check out our question, then you see that it's empty. So it's no longer there because we cleared everything. Of course, we don't want to do that, right? And we also don't want to delete the question number 4. So let's just take this out and log something to the console here instead, just to see that the has method works. All right. So set, get, has, delete, and clear are the most basic methods that we can use to manipulate maps. Now, something else that's very cool is that maps are actually iterable. So this means that we can loop through them, which is another thing that we cannot do with objects, right? So the first way of looping through a map is to use the for each method. And so this means that each map gets the for each method such as arrays do. And all this means is, as you already know, is that the for each method is in the prototype property of the map function constructor. And so all of the maps inherit that method and can then use it. So let's try that. And so we say question.forEach. And such as with arrays, we have access to the current element, to the current key, and also to the entire map. So let's access the value and the key. And I'm actually going to call it like that. So value and key. And let's just log them to the console, okay? So console.log. This is key, and it's set to, and of course it's the value. So let's check this out. And yeah, so here we go. So all our 8 elements here are now printed to the console. And so this means that we can really loop through a map, which is really handy. So we use the for each method, but we can also loop using the for of loop that I showed you before with the arrays. So this kind of loop doesn't only work for arrays, but also for maps. So let's try that out as well. So for, and let's say key, and then the of. So for of question. Now, what if we wanted to access not only the key, but also the value? In this case, we would once again have to use destructuring. And so this is yet another case of destructuring. So instead of simply using the questions variable, like here, like I did here, we use question.entries. So just like this. And what this does here is to return all entries of our questions map. And we can then use destructuring to store the key and values in 2 separate values, such as we did before. So remember, destructuring is using these brackets, and so we simply say key and value. So once more, using the entries method here on the question is going to return all the key value pairs. And we can then use destructuring, such as we did before with arrays, and store the keys and the values in 2 separate variables that we can then use here inside of this for of loop. And actually this also works for arrays. So if you're curious about that, you can simply go try that out, and I'm sure that you're going to make it work. So let's now do the exact same thing here just to see if it works as well. So I'm just going to comment this one out so that it doesn't get in our way. So if I reload this now, we actually get an error, and that's because there's one parenthesis here too much. Okay, but now here we go. So everything works as expected as it did before. So let's now, instead of printing all of the elements in our map, let's use this to only print our 4 answers here, okay? And the way that we do this is to say that we only want to print the value if the key is a number. So that's the beauty of having this custom data type here for the key. So remember, in maps, the key cannot only be strings, but also like numbers or booleans like down here. And so we can use that to our advantage right now. So we can say that if the type of the key is number, and that's actually that we didn't do before. So you're still learning a couple of new stuff here in this section, which is great, right? So we can use this built-in JavaScript function to check the type of a variable. And so in this case, we only want to execute this part of the code here if the key is a number. And what we want to do in this case is to simply console.log the answer, okay? So answer, then number key, and then of course the value. And that's it. Okay, and to make our question here look a bit better, we just want to get rid of this and of this output here, right? So let's take this out and this one as well. This was just for testing purposes before. So now we have our question and our 4 answer possibilities. What we need to do next is to actually get our answer. And we did that before in one of the coding challenges, and I'm going to do it again right now using the prompt function, which simply opens a pop-up window and asks for an answer. And I'm going to declare it as a constant and call it ans for answer, and then say prompt write the correct answer. So here the user can write 1, 2, 3, or 4. Now the problem with this is that JavaScript is then interpret this as a string, so as text. And so we need to also convert this to a number. And so we use another built-in JavaScript function, which is called parseInt. So this is going to be converted to an integer. Okay, and so now the answer will be a number. So as long as the user enters one of the numbers, of course. If the user inputs text, then JavaScript will not be able to convert it to a number, but we're just going to suppose that the user inputs a number here. Okay, and what do we want to do next? We want to display this string here, so correct answer, if the answer is true, or this string here, so wrong, please try again, if the answer is false. So how can we do that? We could of course go ahead and write an if-else statement like we would have to do if we were storing this data in an object, but we're not. And so we can use, once again, to our advantage, the fact that we stored these 2 strings here with the keys of true and false, so as booleans. So all we need to do is to retrieve this string if the answer is correct, and retrieve this string if the answer is incorrect. So the first thing is to compare the answer with the true answer, right? So we say question.get answer. And so if the input is the same as the correct answer, then this expression here will be true, right? And if it's incorrect, then of course it's false. And now you can see once again the beauty of using true false as the keys, because now all we have to do is to say question.get and then use this here as the key, because this will either read true or false. And so if it's true, it's going to retrieve the string for true, and if it's false, it's going to retrieve the string for false. So this is very useful and very handy, so we don't have to write an if-else statement here. We can simply do it like this. Okay, so let's now console.log this so that we can actually see it as our output. Okay, so let's load this and input the correct answer. Let's say 4. And so wrong, please try again. So yeah, it's working. Now if I say 3, which is the correct answer, then we still get wrong here. Okay, so something is not working. Let's see. Oh yeah, and that's because we called it correct here, but then answer down here. So of course, it needs to be correct so that we read the correct value. So let's try it again with number 4. So it says wrong, please try again. And now with number 3, which is the correct answer, and now it says correct answer. So yeah, this is really working. So maybe this part here was a bit tricky and a little bit hard to get used to, but I hope that you really understood it. And if not, then just pause the video and take a look at it again. So now you probably wonder why maps are actually better than objects to create hash maps, right? And there are a couple of reasons. So let's summarize what we learned in this lecture. So the first reason why they're better is because we can use anything as keys, which opens a lot of possibilities, as we just saw with this example. And second, because maps are iterable and making it very easy to loop through them and to manipulate data with them. And reason number 3 is because it's really easy to get the size of a map using the size property and that can also be very handy. And finally, because we can easily add and remove data from a map. So all of these are strong arguments in choosing maps over objects if we want to build hash maps. Alright, so I hope that all of this makes perfect sense to you and that you start using maps if you choose to get started with ES6. Okay, so see you soon. Let's now talk about one of the biggest additions to ES6, and that is classes. Now, classes actually don't add anything new to the language. They're just synthetic sugar over the way we do prototypal inheritance in JavaScript. And that means that classes simply make it easier to implement inheritance and to create objects based on blueprints. So in ES5, these blueprints are called function constructors, right? And we added methods to their prototype properties in order to make all the instances created through a function constructor inherit these methods. So let's start by doing that now, and then write the same code with ES6 classes after that. So ES5, and I'm going to create a person function constructor. So the one that we already know very well. So person5, because of ES5, is a function which accepts the name, a year of birth, and also a job. Okay, and I'm writing it as a function expression here, okay, but I could also equally have written it as a function declaration, so it works the exact same way. So all of this is nothing new. Okay, so this dot year of birth is year of birth, of course, and finally the job is a job that we input. Alright. And now to make all the instances inherit a calculateAge method, it's as easy as adding it to the prototype property of the function constructor, right? So all of this is nothing new, but so here we can practice it a little bit more, okay? So the age is, and let's actually create a new date here so that we are always up to date with the year. So get full year minus the year of birth. And let's then simply log this to the console. So very simple stuff. And just to test it, John 5 is a new person called John, born in 1990, and let's say that he's a teacher. Okay, so this is the way that we used to do it in ES5. Let's now do the exact same thing, but using ES6 classes, so that you can see the big difference. And so we use the class keyword, and then we simply say the name of the class, which is similar to the name of the function constructor that we used before. So this should be called person, and I'm going to call it person6 here. And that's it. So it looks a bit like a function declaration, right? But this is actually a class declaration. And the way that a class declaration works is that all classes have to have the constructor method. Okay, so we have to write constructor. And this is where we define the initial properties that we want in our object. So again, it's going to be, of course, name, year of birth, and the job. And then this looks like just a regular function. And what we then do here is the exact same thing as we did before. So we have to say this name is equal to the name that we pass in. This dot year of birth should be year of birth, which is the one that we pass in here. And of course the same with the job. Okay, so again, this part here, the constructor part, which every class declaration has to have, is very similar to this part here of the function constructor. Now, if you want to add a method to this, we simply do it also here in the class. So all we have to do now is to say calculate age. And that's it. Now we can add our code in here. So there's no function keyword here, no prototype like we had to do here. No, all we do here is to simply add this new method right to our class. And note that we don't have any separating punctuation here. Okay, so no commas or no semicolons like in objects, for example. In here, in the class definition, we don't need anything like that. Okay, so I'm just going to copy the code from the calculate age method there to here, because everything is going to work the same. And that's it. So this class here is now effectively the exact same thing as this, but it's nicely structured here into this entire class, and it looks a bit better and is also easier to write. And so that's why we say that it's synthetic sugar. And let's now create an instance of this class, and I'm going to make it a constant. So John 6 is a new person 6 called John, also born in 1990, and he is also a teacher. And what I want to do now is to actually show you in the console that these two things are the exact same thing. So let's take a look at them here in the console. So John 5 and John 6. And let me open them. And here we see that they actually look the exact same, right? So all of these are the same. The prototype is still the object. And in here, we inherit the calculate age method that we defined up here. Okay. And then in here in the prototype, we also have the calculate age method, which is of course this one here. So writing it like this is under the hood of JavaScript, behind the scenes, converted to the exact same thing as we wrote in the old way. So again, this is just synthetic sugar, which makes it easier to write classes than it was before. And actually, there are some people criticizing classes because they basically hide the object-oriented nature of inheritance in JavaScript. And so some beginners who don't learn about that, they may never really understand how inheritance works behind the scenes in JavaScript. But you do understand it, right? And so you're 100% ready to start using ES6 classes. Now, another thing that we can do with classes is to add static methods. And static methods are methods that are simply attached to the class, but not inherited by the class instances. So by objects that we create through that class. So I actually think that this isn't really helpful, but I still wanted to show it to you. So let's say that we want to add a static class here, simply called greeting. And all we do is to log something to a console. Let's say, hey there. So we can use this like as helper functions. So in order to use this, we cannot use it on John because it's a static method. And as I said, these instances are not going to inherit it. And so all we can do is to call it like this. So person5 dot greeting. So it's basically a method that is attached to this class definition. And this class definition is under the hood, behind the scenes, a function definition. And so it's also an object, as you already know. And so we know that we can attach methods to an object. And so that's simply what we're doing here. So if we now reload this, we get this error here, and that's simply because I misspelled it. But now, of course, it works with our hey there string logged to the console. So again, that part I think is not really useful, but we can still use it if we want. All right, so that's it for the fundamentals of ES6 classes. Just two more things that I need to say here. And first, class definitions are not hoisted. So unlike function constructors, we need to first implement a class, and only later in our code we can start using it. So this is a very important thing to keep in mind. And second, we can only add methods to classes, but not properties. But that's not a problem at all, because inheriting properties to the object instances is not a best practice anyway. And so that's why this rule is now really enforced here in classes. Okay, so in the next lecture, we will see how to implement inheritance from one class to another. And that's a very cool topic, so don't wait and move right to the next lecture. Now that we are ready to use ES6 classes, let's take it one step further and implement inheritance between classes using subclasses. So, do you remember this slide from when we first talked about inheritance? We had this example where we had two function constructors, or ES6 classes, which is like the same thing, that can inherit from one another. So we have here the more generic class person for all persons, and then we have the more specific subclass for an athlete, because an athlete is also a person, but with some more specific attributes and also methods. And so it makes a lot of sense that we make the athlete class inherit from the person class, right? Now, we have actually never implemented this in our code up until this point. All we did was to make objects inherit methods from their prototype. But this inheritance between classes is really taking it even one step further, and so that's something really cool and sometimes really useful too. So, such as before, let me first show you how to do it in ES5, and then we move on to classes and subclasses with ES6. First of all, let's get back the code that we wrote before for ES5, so that we don't have to write it all over again. So this person5 function constructor, or let's call it class, will be our superclass. So let's now create the subclass, which will be the athlete class. And this is how we do it. So athlete and 5 again as a function, and in this function we actually have to pass in these exact same parameters here as well. So let's just copy them. Okay, so if you want an athlete, we need to say their name, their year of birth, their job, and we also want to define to how many Olympic Games they went. So let's call it Olympic Games. And also how many medals they have won. So medals. Okay, and now in this subclass, the first thing that we have to do is to call our superclass, which is person5, right? So let's do that, person5, and we actually now have to use the call method. And I'm going to explain you why in a second, okay? So let's first write the code, and then I'm going to explain it to you. So this will be set to this, and then we pass in the 3 arguments that we have. So name, year of birth, and the job. And we can only pass the 3 arguments into here because we received them in this function call here as well, right? And that's why we have to have them here and also in here. Okay? And now it works like just it worked before. So we say Olympic Games is equal to Olympic Games, of course, and this dot medals is medals. So why do we have to call the superclass function constructor with this as the this keyword? And I'll give you a second to pause the video and think about that. To explain this, we need to remember how the new operator works, which is the operator that we use to create a new instance. So when creating a new athlete object, new creates a new empty object, calls the athlete function constructor, and sets the this keyword to the newly created empty objects. So you remember that part, right? So in the execution context that we're in here, the this keyword will point to the new empty object. Now, if we want a person property's name, year, and job to be set on a new athlete object, then we need to call the person function constructor with the this keyword also set to our newly created athlete object, right? And that's exactly what we do here. So after this, all the properties will be set in the new athlete object that's created by the new operator. And that's why we need to call it here and to set the this variable to this. Alright, and now to create the correct prototype chain, we're going to use object.create. Because remember, object.create allows us to manually set the prototype of an object. And we want the prototype of the athlete to be the prototype of the person, so that they become connected. So let's quickly do that and say athlete5.prototype object.create person5.prototype. And that's it. So now the two function constructors are connected and the prototype chain should work just fine. So let's actually take a look at that in the console. And so I'm going to create a new athlete here. And I'll say John athlete 5. So it's a new athlete called John. So remember, we have to set all of these properties that we would set on a person also on the athlete. So John, born in 1990. And now let's say that he's a swimmer, that he went to 3 Olympic Games where he won 10 medals. So quite a great athlete. And let's now reload this and take a look at John the athlete. Okay, so here we go. So we see all of our properties are defined here in the athlete, and we also see that our prototype is the person 5. And that means that the athlete 5 function constructor's prototype property is the same that person 5's prototype property. And so in here we have the prototype of person 5, and then of course we have to calculate age function here. And what this means is that the prototype chain works exactly in the way that I showed you in the section where we talked about all of this. So let's now test this. So I'm going to write John athlete dot calculate age. And if I now reload this, then we actually get this error here. All right. So something must be wrong here in this method. Okay. So let's take a look. New date. Okay, and here it is. So this of course is a method. So get full year is a method. And that's why it wasn't working probably. So let's try it again. And alright, so 26 is the age. And that once again worked because not only all the instances of person can now inherit this method, but also all of the instances of the athlete class can inherit this method. Because as we did here in this line, the athlete 5 class inherits from the person 5 class. So again, person 5 is the superclass and athlete 5 is the subclass. And of course we can also set methods on the prototype property of the athlete 5 function constructor. So let's do that. Dot prototype dot won a medal. So this is a method that's very specific only to the athletes, and so all the instances are going to inherit this method if they are athlete instances, of course. And the person instances, they will not inherit this method because it's only in the athlete 5 prototype property. So this method will very simply increase the medals of the athlete plus plus, so increase by 1, and then log it to the console. And so now we can also use this one here. Won a medal. So let's try it out. And we got an error saying that one medal is not a function. And that's because it actually has to be after we connect these two function constructors with this line of code here. So we first set the athlete 5 prototype property, and then we can add methods to that very prototype property. Okay, and so now it's going to work. And we see that he has 11 metals now. So we started with 10 and now we have 11. So let's now just take a final look at the object in the console. And so now we'll also find the one metal here in its prototype property, which is exactly what we did here. And then of course also the calculate age function here further down in the prototype chain. Great, so now you learned how to connect to function constructors in ES5. So let's now do the same thing in ES6. And so once again, first I'm going to get back this class. Okay, so this is for ES6, and this here is our person. Let's just get rid of this method that we don't want, and let's focus on what we need. So we have our super class here, and now comes the fun part where we create a subclass of the person. And this is actually way easier to do in ES6 with the ES6 classes than with the function constructors like I showed you before. So all we have to do is to say once again class, and this one is called athlete6, and then we just use the extends keyword. So we say that this class extends the person class. Okay, and so always in the subclass we need to say that it extends the superclass. And then we of course once again need our constructor. And remember, all classes need to have this very method. And then in the same fashion as we had to do before with function constructors, we have to repeat the person properties here if we also want them on our athlete. So name, year of birth, job, and now remember what we want to add here is Olympic Games and medals. Now what we did before was to then use in the subclass this call method to call the superclass with the this variable set to this. Now here in classes we have to do something similar, but it's also easier because all we have to do is say super, and this will then call the superclass. And we don't have to manually set any this variable or anything. Everything happens automatically behind the scenes and we don't have to take care of any of that. So of course we call the superclass using name, year of birth, and job. And that makes sense, right? Because these are the exact same parameters that we have in the constructor of that class. And now we just say this dot Olympic Games is equal to Olympic Games, and the medals are medals. And that's it. So let's also add our method here. And so it's the same code as we had before. So this dot medals will be incremented by 1 unit. And then let's just log it to the console. So let's use this class and create yet another John athlete. So John, born in 1990, he's a swimmer, went to 3 Olympic Games where he won 10 medals. And just to check that everything works the same, we're going to call the same methods that we called before. So John athlete 6 dot won a medal, and John athlete 6 dot calculate age. So let's check it out. And we have a bug. Super keyword is not expected here. So here it's not expected. So it's actually because this is misspelled. So constructor. Okay, so now it should work. And yeah, here we go. It now says that the age is not a number, But that happened because we also had this bug here that we had before. So if we fix this, then it's going to work here as well. So it gives us the same age and the same metals, so everything works the same. But if you take a close look at it, then you have to agree that it's way easier to write it this way here, so these two class definitions, than to write all of this here up, just everything like this, and we have to add of this line of code here, and it all looks a bit strange. So I clearly prefer to do it the ES6 way with the class definitions. All we need to make sure is that we really understand what happens behind the scenes and what prototypal inheritance is and how it works and why doing these classes like this works the way that it does. And just to show you once again that these classes are just synthetic sugar, let me show you these athletes here as well in the console. So to prove you again that they look the exact same way. So this is the functioning prototype chain in the way we did it before with athlete 5 and person 5, and then what we did right now. And so we see, if we make this bigger, that it's the exact same thing. So this prototype chain here is the exact same as this prototype chain. Alright, and so with these two final lectures about classes, you now truly understand everything that there is to know about prototypal inheritance in classes in both ES5 and also ES6, which is really great. Hey there! It's now time for the final coding challenge in this course, so that you can apply some of the new ES6 features that you just learned in this section. So in this challenge, what I want you to do is to imagine that you're working in a small town administration and that you're in charge of two town elements, parks and streets. And this is a very small town, so we currently only have 3 parks and 4 streets. But more parks or streets may be added in the future. Also, all of the parks and streets have to have a name and a build here. Now, at an end of the year meeting, your boss wants a final report with the following data. First, he wants to know the tree density of each park in the town, and that's calculated by dividing the total number of trees by the park area. Second, the average age of each town's park, and that one is calculated by adding up all of the ages and dividing it by the number of parks. The third data that your boss wants to know is the name of the park that has more than 1,000 trees. So your boss knows that there's one park like this, but he wants to know the name of that park. Okay, and as of the streets, we want to know the total and average length of the town streets and also a size classification of each of the streets. And they should be classified into tiny, small, normal, big, and huge. And if the size is unknown, then the default is simply normal. And all this report data should be printed to the console, so that it looks a little bit like this output that I have here. So we have the average age of our parks, and then in here we also have the tree density of our 3 parks, and finally the park that has more than 1,000 trees. And for the streets, we have the total and the average length, and then the size classification for all of the 4 streets. And that's it. Now in this challenge, I'm not going to give you detailed steps on how to solve it like I did before, because I think that you're really ready to do it on your own at this point. And that being said, the goal of this challenge is of course that you use some of the ES6 concepts that we talked about just in this section. Things like classes, subclasses, template strings, default parameters, maps, arrow functions, and destructuring, for example. And of course, you don't need to build anything super fancy here, because all I want with this challenge is for you to practice some of the new ES6 features here in this challenge. So good luck with this one, and if you struggle with anything, then you can just watch the next video to see my personal solution to this challenge. But first, please try to do it on your own. Alright, I hope that you actually completed the coding challenge on your own and really started to use all these new features. So let's see how I did it. So we are in charge of two town elements, and these are parks and streets. And they both have in common that they have a name and also a build year. And so what I'm going to do here is to create a class, which is going to be a superclass that contains the name and the build year. And then for each of the park and street, I'm going to have a subclass. And each of these subclasses will hold their specific attributes or properties and also their specific methods. So let's implement that. So class element, and the constructor is the name and the build year. So the name and the build year. And that's actually it. So this is our element superclass. We could also, of course, add some methods in here that all of the park and street elements could then inherit. But I guess that we're not gonna need that for this small exercise. Okay. So let's now create the park class. And remember, since it's a subclass of the element, we need to use the extends keyword. So extends, and the superclass that we extend is called element. All right. So we need the constructor. And as I explained in the last lecture, we need to repeat the property names that we have in our super constructor, which is called element in this case. So again, name and build year. And then what we also have is the area and the number of trees. So we saw in the exercise that we want to calculate the tree density and that it's calculated by dividing the total number of trees by the area. And so of course, we need to have both of these properties in our object. So the first thing that we do in a constructor of a subclass is to call the superclass. Okay? So name here and build here. So all of this is nothing new for you at this point. So area is of course the area that we pass in, and the same for number of trees. Okay, and so let's now add a method for calculating the tree density of an object. So tree density So as I mentioned in the previous video, this is calculated by dividing the number of trees by the area of the park. And so of course it should be the number of trees divided by the area. And that's it. And since we're building something very simple here, we're just gonna console.log the result of this calculation, since that is the final output that we want. So instead of returning it, such as we would do in a real app, we're just gonna log it to the console. So let's now use a template string here, and I hope that you did this one as well, because this is one of the easier measures to implement. So what I'm gonna do is to say the name of the park has a tree density of, and then our density value, trees per square, and I'm going to use the square kilometer unit. And so in here, the unit that we'll have to put in here will always be a square kilometer. So I'm just putting it at a comment here so that we later know that that's the unit that we're going to use here. So this is not specific to JavaScript. It's just, we could also use square miles or something else, but I'm going to go with square kilometers. And that's why I'm putting it here in the text. So this should be it for the park. Now let's add another subclass for the streets. So class street. And of course, this one is also going to extend the previous element class. And I'm sure that you know what comes now, which is the constructor, right? So of course, once again, the name, the build year, and now we need two other properties here, which is the length, so the length of the street, and the size. Because remember, in our final report, we need to say the average and total length of all the streets together, and also a classification of the size of each street. And the classification is tiny, small, normal, big, or huge. And so here, as the size parameter, I'm gonna pass in a number for each of these, and then write a method later on that will then classify the street based on this number. And remember that in our text, it said that the default should be normal. And so we're gonna have a default here, but I will leave that one for later, and I'll put it here when we write our method to classify the street. So it will be just in a second. So let's just finish this one and then we write that method. So again, we first need to call our superclass with the name and the build year. And then we need to set our own properties. So the length will be the length and the size. All right, so let's now write that method that I was talking about called classifyStreet. And I'm going to use one number for each of these classifications. So tiny is going to be 1, small is going to be 2, normal is going to be 3, big is going to be 4, and huge, it's going to be 5. So what does this sound like to you? To me, it sounds a lot like we're doing a hash map here, right? And so we're going to make use of the new ES6 feature, which is the map. So let's create a new variable, and I will call it classification. And I'll create a new empty map here. So classification.set, and I'm going to say the number 1 is for tiny. Two is for small. And let me just duplicate these a couple of times. So 1, 2, 3, 4, and 5. And this one is going to be normal, big, and huge. And so when we put in a size here then as an argument, we can use that argument to simply read our classification out of this map here. Because we can make use here of the fact that we can use something different than a string for our keys. So it's different from the objects that we used to use before for this kind of thing. Now just remember that part where I said that we want to be normal to be the default. And so we can make use of default parameters here in ES6 and simply set this one to 3. So now if we create a new street and don't specify this argument, so we can just specify name, build year, and length, then the size will automatically be 3. And then the street will be classified as normal. All right, and so now we can just log it to the console. Once again using a template string here and say that the name, so the name of the street in this case, and we can also use the year now in this case, so we can say the street which was built in. So just to give some more information to the console and also to use the variables that we have available, is a... Okay, and now how do we get the data out of our map? Remember that? Right, we use the get method. So we simply say classification.get, and then we need our number, which is the size. And so of course we can get that by saying this.size. And that's it. So the name of the street built in a year is a normal, for example, street. And that's it. Now with this method, we can classify our street. So we now have all our classes or data model, let's say so, defined. So now it's time to create some data. So to create some objects. And we're going to start with the parks. So I will create an array which will contain all of our 3 parks, because remember, we have 3 parks and 4 streets. So I will say all parks so new park. The first one, let's call it the green park. It was built in 1987, has 0.2 square kilometers of area, and has 215 trees. Okay, so that's the first one. Now let's make a new park. This one is going to be called the National Park. So this one is going to be a bit better or bigger. So this one is old, 1894. It has 2.9 square kilometers and let's say 3,541 trees. So really a huge one. And now the third one. Let's call this one the Oak Park. Built in 1953. 0.4 and 949 trees. Okay, so now we have our parks. Let's now create the streets. So the first one, and I call it the Ocean Avenue. Built in 1999, 1.1 kilometers length and a size of 4. So this will then be classified using our classify method, right? So next one, and this one is the Evergreen Street. Built in 2008, 2.7 kilometers, and a smaller street. So I'm just putting kind of putting random data here for a very small town. You could of course put data for your own town or whatever. And maybe you noticed that in here, in this line before, I didn't specify this last parameter here, right? So this is the size one. So just to see what happens when I don't put anything in. So just to show that this default parameter here is going to work. Okay, and just the last one. Let's call this one the Sunset Boulevard, which is a beautiful name, I think. 1982, 2.5. And this, with this beautiful name, it has to be a huge street. So number 5 here. All right, so let's now start generating a report. And what I'm going to do is to write one function for each report and then pass in our array which contains our data. So for the parks, I'm going to pass in this one, and for the streets, of course, this one. So function report park, and I'm simply going to call it P here. And I will also already define the other function here so that we then just have to fill it. So report parks and report streets. And this one is called S. And I will also just call them. So report parks with all parks and report streets with all streets. So again, in this exercise, I don't want to write any fancy code like we did in our big app project, but instead I'm really focusing here on using some of the ES6 features, okay? So just very simple functions and very simple data structures. So let's start with the parks report. First one, I'm going to print is simply say parks report to make it well visible here in the console. So what do we want here? Let's take a look at our exercise. We want the tree density of each park, right? Then we want the average age of the town's park. This actually doesn't make much sense. So it's average age of the entire parks. And then we also want the name of the park that has more than 1,000 trees. So these three things are about parks. So let's put it here. We want the density. We want the average age. And which park have more than 1,000 trees. So the first one is really simple. So for each of our park objects, we want to call the, the tree density method, right? So we have 3 parks in our array, and for each of them, we want to call that method. So it makes sense that we loop through them, right? And for that, we're simply going to use the for each method. And in our callback function, we only want the current element. So this one is for the current element. And then on that element, we can call the tree density method. And that's it. So again, we loop through all of our parks. And for each one, we simply call the tree density method, which is then going to print to the console the density. So let's try that out. And we have some kind of bug here in line 658. So we already wrote a lot of code here. So 658. And here it is. And yeah, so I forgot these parentheses here. So such like regular functions, of course, all of the code has to have these parentheses. So let's try it again. And another small mistake, line 641. And yeah, so here I see the problem. I have num trees here, and here I misspelled it. Okay. And let's hope. Yeah, so now it works. Great. So the green park has a tree density of 1,075 trees per square kilometer. This one has about 1,200, and this one has about 2,300 trees per square kilometer. All right, so that part is already working. So let's now talk about the average age thing. And what I'm going to do here is to create an external function which is going to calculate the average and the total for any array that we input into that function. And so this way we can then reuse it down here in our report streets function to calculate the total and average length of all the streets. Okay, so let me do that out here. And I'm simply going to calculate it calc, because that's what we do. We calculate stuff based on an array that we receive. So we want the total and the average. Now there's an extremely handy method that I didn't show you before, and it's called the reduce method. And the reduce method is used to basically reduce an array to a single value. And it's actually an ES5 method, so it's nothing new with ES6. It's just one of the ES5 methods, similar to for each or map, because all of these loop through arrays. Now the difference is that this one loops through an array to accumulate all the values into a single value. So this is perfect for adding up all of the elements in an array. So let me show you how this one works. So let's say we want a variable called sum. And so we use the reduce method on our input array, of course. And now in here, as with all our other methods like for each and map, we can use a callback function. Now what's different about this one is that we not only have access to the current value and the current index, but also to the previous value. So let me write that out actually. So previous, the current, and the index. Okay, and we're not going to use all of these, but I just want to write it out here so that you have this kind of as a reference. And then what we need to return is, in the case that we want to sum everything, the previous plus the current. And that's actually it for the callback function. Now another argument for the reduce method is the initial value of the accumulator. So the number at which we want to start. So in this case it's going to be 0 because we want to start with our sum at exactly 0. If we wanted to add everything to 100, let's say, then we could put 100 in here. But that's of course not what we want. So imagine that we had an array with 3, 5, and 6, like this, okay? Just as an example. So the previous value would then be 0 in the beginning, because that's the initial value that we defined here. And then here in our callback function, our previous plus the current would be 0 plus 3, okay? Then in the next iteration, the previous value would be 0 plus 3, which is 3. And so what we had here would be 3 plus 5, so 8. Then in the next iteration, it would be the previous, which is 8, plus 6, which is 14. And so the final result would be 14. And we had then reduced all of the elements in the array to a single value, which is 14. Now, of course, we can use different things in here. For example, we could multiply them, or we could divide or subtract, or even other things. But now, all we want to do is to simply add all of these elements together. And this reduce method is perfect for that. And so let's now return that sum and also the average. Now we can use the concept of destructuring that I showed you in one of these lectures, in which we simply return an array of 2 elements, and we can then use destructuring to save these elements into 2 different variables when we call this function. So return, of course, the sum, and then the average, and we can calculate it right here, because it's very simple. The average is simply the sum of all the elements of an array divided by the length of this array, right? So sum divided by array dot length. So that's it. This is actually all that we have to do in this function. So let's now use it down here. And as I was saying, we can now use destructuring. So const total age and average age. Now, what do we pass into this calc function? We want an array of all the ages of all the parks, right? So let's maybe first calculate this. So we want to calculate the ages. So const ages. So what we're going to do is to loop through all of the elements of our park array and calculate the age for each of them. And we could actually write a different function for that, but I'm not going to do that right now. But of course you could totally do that, okay? So if you want, feel free to do that. So I'm going to use the map method to loop through all the arrays. Then I want the current element, and then the age is very simply 2016, so the current year, minus, of course, the build year. Okay. And let's actually replace this with a new date, get full year, so that this is always up to date. And so like this, we will have here an array with all of the ages for all of the parks. So we saved both of the variables here, so one with the age and one with the average, using once again the concept of destructuring. But all we need here is actually the average. But that's no problem, we can just ignore the total. And so I'm going to print to the console that, or let's put here the number of our parks. So it's p.length, obviously. Have an average of avg age, years. Okay, and that should be it. Let me check it out. Okay, so date, get full year is not a constructor. So this is what I was missing here, these parentheses. And now current is not defined. So 681, of course it's cur here. And I'm sure that you saw it coming, but I didn't. But now it works. Okay, so our 3 parks have an average of 71 years. Alright, and now finally let's take care of this last part here, which is to determine which park has more than 1,000 trees. So to me it makes a lot of sense to use the very new ES6 method called findIndex, which, remember, we use on an array to get the index of the element of the array which satisfies or a callback function. So let's first get all of the numbers of trees into an array and then use the findIndex method on that. So what we're going to determine here is an index. So I. And so let's first get all of the number of trees, and these are of course stored in our P array. So we loop through P and then store all of the tree numbers into a new array. So from the current element, we want to read the number of trees property. Alright, so this one returns us an array. And since this one is an array, we could now immediately put the next method here, so we could chain these methods. So in order to write less lines of code, let's do that. Now what we want here is to find the index of the element that is larger than 1000, right? So it's simply this. Element greater or equal to 1000 trees. And that's it. And we didn't use the find method here. Remember that we have the find and the find index method here, which are both new. But we didn't want to use the find because we're not interested in the number of trees, but in the index, so that we can now select the correct park and retrieve its name. So that's what we're going to do now. Console.log. And we can simply say that we want P number I, and then its name has more than 1000 trees. So, does that make sense to you? Let's check it out. And that's right, the national park has more than 1000 trees. And let's see it, and it's actually true. So this one only has 215, this one has 3541, and this has 949. So this is the correct answer, and so it works. So all that's left to do now is to do the report for our trees. So let's copy this one here, and not trees, of course, it's streets. All right, so what do we want here? Let's go check our text here. And we want the total and average length of the town streets. Let's actually copy this one and then classify the sizes. And classify the sizes, which should be very easy. Now we already have our function which does this, right? So now all we have to do is to reuse it. And again, using the structuring, we can write total length and average length. So we use a calc function, and now let's actually directly get all of our length, and we're doing it the same way that we did before. So s.map, then the element, and then simply retrieve the length of each of them. So this builds us our array with all the length that we can then pass into the calc function. Okay, let's now log it to the console. Once again, we're using a template string and say, or the number of streets here, such as I did before, streets have a total length of obviously kilometers, with an average of average length kilometers. So let's check it out. And here we go. Our 4 streets have a total length of 7.1 with an average of 7.775. And ignore these values here. This is a weird bug that JavaScript sometimes has. So of course it should be simply 7.1, but the JavaScript engine sometimes gets a bit confused and it adds all of these 0, 0, 0 and then some random value here. So not to worry about this, the correct result is 7.1. So you can simply ignore these strange number here, and the same thing of course in here. And now all there's left to do is to classify our streets. And so that's very easy as well. We just need to loop through all of them and call our classify street method. Okay. And so here we go. Ocean Avenue, 1999 is a big street, a small, a normal, and a huge. So remember here in the third one, which is called the fourth street, I did not pass in any argument, but it still was classified as a normal street, and that's because, as I showed you, the default parameter here is set to 3, which then maps to normal. Alright, and that's actually it. So our report now has all of the things that our bosses asked us to include in the report, right? So with this, we conclude our coding challenge, in which we used not all, but at least some of the new ES6 features. What you can do now to practice ES6 even more is to, for example, convert code that we wrote before to ES6 code. So for example, you can redo the older challenges, but this time write it in ES6. Or you could even, if you really feel like it, convert our budget app project to ES6. So that should be a lot of work, but if you feel like it, then it's of course one of the tasks that you can do. Alright, so have fun with that, and see you in the next lecture. In this section, we're going to talk about asynchronous JavaScript, which basically is just a fancy term for some code that keeps running in the background while our main code is still executing. And typically that is for stuff like requesting some data from a remote server like an API. So in this section, I'm going to give you the tools to work with asynchronous JavaScript in a very modern way, because it actually works quite differently from what we've been doing up until this point. So let's now quickly move on. In this lecture, we will take a look at a very simple example of asynchronous JavaScript. So this is a completely new concept that we've never touched in the course up until this point. And so I'm very excited to show you what asynchronous JavaScript is all about. Now before we actually start, you're maybe noticing that I'm using a different code editor here. And that's because this part of the course was recorded shortly after the rest of the course. And so now I switched to a new editor called VS Code. And if you're interested in that one, you can simply go download it here from this website. But of course, you can also simply follow along using the code editor that you already have. So let's close this one here. And I already opened the file for this section here and also the browser here on the right side. Now what's also different here is that before I used to have an external JavaScript file called script.js, but right now I choose to simply write the code here in a script tag right into the HTML. I find it easier to just do everything in one file instead of having multiple files here. Okay, so let's just write some code here right into this script tag. And we're going to start with just some old school synchronous JavaScript code, just the way we've been doing up until this point. Okay, so let's write a function called first. And you're noticing here probably already that I'm using the new ES6 syntax, right? So I'm using the const keyword here to declare a function expression using then here the arrow syntax, right? So that's the new stuff that we learned in the last section where we talked about ES 2015 or ES6. And so from now on, I'm going to start using this new syntax here in this section and also in the next one. Okay, so let's just log something to the console here. Hey there. And then we're going to call this function here as well. Give it a save, reload it here, and then open up our console. And so now we know that everything's working here, right? So our hey there text is actually being printed. Let's now add a new function. This one, just call it second. And in this one, for now, I'm going to log some other text, and I'm going to log second. Then in the first function, we call the second one. So just second. And then a new console.log down here, simply saying the end. Okay, and this will make more sense to you in a second when we start adding something different here into the second function. For now, we simply have hey there here as a result, which comes from here, then the second function is called, which logs second, as you see here, and then finally the end. Okay? So all of this is synchronous JavaScript, just the way we've been doing up until this point. And with synchronous, I mean that all the instructions are executed one after the other, line by line, just in the order that they appear in the code. And so that's exactly what we have here. But now let's actually add some asynchronous code here. And in order to do that, we are going to use the setTimeout function, which is basically to set a timer in JavaScript. And that will then allow us to write code that should be executed later. Okay, and so that is asynchronous JavaScript. So let's get rid of this one here. And now I can call the setTimeout function. So setTimeout function is a function that we can pass a callback and also the time. So first is the callback. And again, I'm going to use the arrow syntax. So no arguments here. And then the content of the function in here. And then the second argument we pass into the setTimeout function is for how long we want the timer to run in milliseconds. Okay, so I'm going to put here 2000 milliseconds, which means 2 seconds. And after these 2 seconds have passed, then this callback function that we passed in here will run. Okay? And this callback function here will be very simple. All I want to do is to actually log something to the console. Let's say async, hey there. And let's get rid here of this side panel. Okay, so let's review what we have here. First off, we call the console log. Then we call the second function, and then in the second function, we call this timer here, which after 2 seconds will then run this function here. Okay, and then after that, we run this console.log, which will log the end to the console. So what do you think the result of this code will be? Can you guess that? So let's take a look. And you saw that appearing here after 2 seconds. So first we had hey there, then the end, and only after 2 seconds then appeared the async hey there. Let's try that again. Let's wait for it. And here we go. Now maybe you expected that first only the hey there appeared, then we call the second function, then this timer is run, and then after 2 seconds it would then print the async hey there, and only after that it would print the end. Maybe that was what you expected, but that's simply not how JavaScript works with asynchronous code. Okay, and I'm not going to go into a deep explanation here at this point, because that's what I'm going to do in the next lecture. So in the next lecture, you will learn exactly how asynchronous JavaScript works behind the scenes with the event loop and the web APIs and some other parts of the JavaScript engine. For now, I just want you to notice that all of this code here run, and that basically the timer run in the background, and then after it finishes, only then it printed here the text to the console, but that didn't stop this code here from running even before the timer had finished. Okay, so this was just a very simple example to show you what asynchronous JavaScript is, and in the next lecture you will then, as I mentioned before, learn all you need to know in order to deeply understand how asynchronous JavaScript works behind the scenes. So after checking out an example of asynchronous JavaScript, let's now dive in a bit deeper and learn everything you need to know about synchronous and asynchronous JavaScript code, as well as the event loop. So all the code we've been writing in this course up until this point has always been synchronous code, which simply means that one statement is processed after the other, line by line, in a single thread in the JavaScript engine. So something like this is an example of synchronous JavaScript, where the first function is executed, logs hey there to the console, calls the second function, which then prints how are you doing to the console, and then finally the end is logged to the console. So one instruction after the other in a synchronous way. Now this here is an example from our previous lecture, and as we learned, this one involves some asynchronous JavaScript. So again, the first function gets called, logs hey there to the console, and then calls the second function. Now this function calls the setTimeout function, which is basically like a timer that will execute the callback function that we passed into it after 2000 milliseconds. However, this will not make the code stop for 2 seconds, but instead the function returns, goes back to the first function and logs the end. Then, after the 2 seconds actually have passed, async hey there is logged to the console. Now, why does the code move on instead of waiting for the timer to finish? Well, before I show you how and why this actually works behind the scenes, let me quickly show you another example. So suppose we select an image from our DOM and pass it into a processLargeImage function that we created. Now, we know that this function is going to take some time to process the image. And so just like before, we don't want the code to have to wait. So we don't want it to stop while the image is processing, because that would be terrible in some situations. So what we do here is to also pass in a callback function that we want to be called as soon as the function is done processing. And just like that, we have created asynchronous code. So that is the whole philosophy behind asynchronous JavaScript. We do not wait for a function to finish its work and then do something with the result. Instead, we let that function do its job in the background so that we can move on with the code execution. We then also pass in a callback function that will be called as soon as the main function has done whatever it had to do. We then move on immediately so that the code is never blocked, which means that it can keep processing the code in a synchronous way line by line. Because if the code is actually blocked, then nothing really works on the page during that time. Like for example, you can click any buttons or anything like that. So in summary, we can use callback functions to defer actions into the future in order to make our code non-blocking. But how does that actually work behind the scenes of JavaScript? Well, that's where the event loop comes in. So the event loop is part of the bigger picture of what happens behind the scenes of JavaScript when we call functions and handle events like DOM events. So we already talked about the execution stack and also about the message queue when we first talked about events. And so this should be nothing new to you at this point. Now, what is new here is the event loop as well as the web APIs, which together with the execution stack and the message queue make up our JavaScript runtime. So this runtime is responsible for how JavaScript works behind the scenes as it executes our code. And it's extremely important to understand how all these pieces fit together in order to execute asynchronous JavaScript. So let's now take a look at how the code from the last lecture is executed inside our JavaScript engine line by line. So it starts by calling the first function, and so as we already know, an execution context for that function is put on top of the execution stack, which can also be called the call stack. In the next line of code, the console.log function is called, and so a new execution context is created and the text is logged to the console. Then the function returns and the execution context pops off the stack. Moving on to the second function, a new execution context is created, and in the next line, the setTimeout function is called, which causes yet another execution context to be created. Now, before we move on, where does this setTimeout function actually come from? Well, it's part of something called the web APIs, which actually live outside the JavaScript engine itself. So stuff like DOM manipulation methods, setTimeout, HTTP requests for AJAX, geolocation, local storage, and tons of other things actually live outside of the JavaScript engine. We just have access to them because they are also in the JavaScript runtime. And so this is exactly where the timer will keep running for 2 seconds, asynchronously of course, so that our code can keep running without being blocked. So when we call the setTimeout function, the timer is created together of course with our callback function, right inside the web API's environment. And there it keeps sitting until it finishes its work, all in an asynchronous way. So again, the callback function is not called right now, but instead it stays attached to the timer until it finishes, okay? And so, since the timer keeps working, basically in the background, we don't have to wait and can keep executing our code. So let's do that. So next up, the setTimeout function returns, pops off the stack, and so does the execution context of the second function, which now returns as well, and so we're back to the initial first function. Now we just log the end to the console, and so we give ourselves a new execution context, print the text to the console, and pop the context off again. Next, the function returns, and so we're back to our original state. So right now, we have executed all our code in a synchronous way, and have the timer running asynchronously in the background. Now let's suppose that our 2 seconds have passed, and so the timer disappears. But what happens to our callback function now? Well, it simply moves to the message queue, where it waits to be executed as soon as the execution stack is empty. And this is exactly what happens with DOM events as well. Remember that? And that's because it actually works the exact same way. So in the case of DOM events, our event listeners sit in the Web API's environment waiting for a certain event to happen. And as soon as that event then happens, then the callback function is placed on a message queue ready to be executed. Alright, so how are these callback functions in the message queue executed? And that's where finally the event loop comes in. So the job of the event loop is to constantly monitor the message queue and the execution stack, and to push the first callback function in line onto the execution stack as soon as the stack is empty. Okay, so in our example here right now, the stack is empty, right? And so we have one callback waiting to be executed, and so the event loop takes that callback and pushes it onto the stack, where a new execution context is created for that function. And that's it. That's what the event loop does. So inside that callback function now, we simply run the log function, which logs async hey there to the console. Then the context pops off the stack and we're done. Now, if there were some more callbacks waiting right now, like data coming back from an AJAX request or the handler of a DOM event, then the event loop would continue pushing them onto the stack until all of them were processed. And that's how the event loop works. It's actually quite straightforward, right? But still, if you ask 95% of the JavaScript developers out there, they will not really be able to explain you this stuff. And so you just gained a huge competitive advantage over them. Now, please just note that the setTimeout function that we used here as an example is really more to simulate a more real-world asynchronous function, like doing an AJAX request to fetch some data from an external API, just like we're going to do in one of the next lectures. Okay? So I hope this made sense to you, so that you're now ready to move on in order to use this stuff in practice. After learning exactly how asynchronous JavaScript works behind the scenes, over the next couple of lectures, we're going to learn how it can be used in practice in our code. So in this lecture, we're going to take a close look at asynchronous JavaScript with callbacks, which is the more traditional way of dealing with asynchronous code. So let's get rid of this code here, but instead of deleting it, I will simply comment it out, okay? So that we keep it here like for future reference, okay? And you can do the same, or you can delete it, you can do it however you feel like, okay? Now, in order to learn about asynchronous JavaScript with callbacks, we're gonna build a very, very small fake recipe reader, okay? And here, we're gonna simulate AJAX calls to get some fake recipes using setTimeouts. So basically, we're going to simulate loading data from a remote web server, which of course would be asynchronous using some timers, like we did in the last lecture. Okay, so let's create a function here called getRecipe. And then down here, we call that function. Now, the way this is going to work is that we simulate first that we get a bunch of recipe IDs from a server, and then based on that, we select a recipe and then get that recipe from a server after that. Okay, so first we get a couple of IDs and then we get a recipe. So again, we're going to use the setTimeout function here, as I mentioned before, basically to simulate the AJAX call, so the call to get the data from the server. So our callback function here, and then let's say this is going to take 1500 milliseconds. So 1.5 seconds. Then in here, let's simply create an array of recipe IDs. And then some numbers. It doesn't really matter here. Okay, and then let's just console log these. And just to see if everything is working, we are reloading it here. And yeah, so after 1.5 seconds, then this code here appears on the screen. Okay, and again, this setTimeout here is just to simulate that this data here comes back from a server. Now, once the data comes back from the server, we then want to get the recipe for one of these IDs. Okay, and so in here, we now need another setTimeout. right? Okay, so basically after we receive this data here from the server, then we need a new set timeout where then the data comes from the server for the recipe. Okay, and once more, this doesn't really come from the server, of course. All of this is just to simulate the asynchronous behavior. And don't worry, in one of the future lectures, of course, we're going to use a real API and real AJAX calls. But for now, we don't want to mess with all that. And so we just use the set timeouts to simulate that behavior. Okay, here let's just put 1 second. And actually, into the set timeout function, we can pass a third argument, which can be an argument to the callback function. So let's say we want an ID argument in this callback function here. So ID, and then we can pass a value here as a third argument, and that will then be passed into the callback function. Okay, so let's then use the recipe IDs that we got from the server in the beginning. Okay, and so now basically this recipe ID 2, which will be 432, which will then be passed into this callback function here as ID. All right, so let's create a fake recipe here in this callback function. And we're going to use an object. So this recipe will be fresh tomato pasta. And then let's also add a publisher. And that will be Jonas. Okay, so that's the fake recipe. Now let's just log it to the console. Console.log. And now in here, I actually also want to use this ID. So just to know that everything's working. And so let's use a template string here. So one of the new ES6 features here as well. And remember, if you want to use one of the variables, then we use the $ and curly brackets, ID, and close the curly brackets. And then we can just write our code. So we say the ID, and then just the title of the recipe. So recipe.title. And that's it. And now let's check out if it works. So after 1.5 seconds, this one here comes, and then after 1 second, we get the recipe. And so basically we chained these two timers one after another by putting this one here inside of the first one. So we have the first set timeout, and then in there we have a new set timeout. And like this, first the first one runs, and then after 1.5 seconds we get this data, and then after yet another second we then get this this fake recipe here. And you also see that the 432 here is actually being passed into this callback function here, just like I said, because we passed it here as a third argument into the set timeout function. Okay, just to see again if this works here, maybe you didn't get the timing here. Let's take a look here at this again. So 1.5, and now 1 second, and here we go. And now just to make things a little bit more complex, let's just add a third level. And let's suppose that we want to get another recipe from the same publisher. So in this case here it's Jonas, and so let's pretend that we want to get another recipe which is also from the same publisher automatically. And so now we use another set timeout with yet another callback function. Okay, so set timeout again. And now we also want an argument here again. And actually we don't even need these parentheses here, right? Remember that with the arrow functions, if we have only one argument, then we don't need to use the parentheses at all. Okay, so publisher, and then just a function body. And this one here, maybe after 1500 again. Maybe this one here as well. I thought this was a bit too fast. Let's get rid of the parentheses here as well. So just ID. Okay, and then of course we also have to pass the publisher into this callback function. And just like before, we do it like this. And this one is stored here in the recipe object. Right, so recipe.publisher. Okay, and so let's now create here another recipe. And this one is Italian pizza. And of course the publisher is the same. All right, let's call this one here recipe 2. Okay, so now we have 3 callbacks nested inside one another. Let's just check if this works. So the IDs, then the first recipe, and now the related recipe from the same publisher, and here we go. And so basically this now is like having 3 chained AJAX calls to get some data from the server. But you see that this is getting here a bit out of hand. Imagine that we had more and more and more chaining here, like 10 levels. Then we would have all of these callbacks here inside of one another. And that is the so-called callback hell in JavaScript. So this triangular shape here that you have here, so this shape here, what I mean here, this triangular shape that we have here, that is a sign of the callback hell, which simply means that we have callback inside of callback inside of callback, which after some time gets really unmanageable. Okay, it gets really messy. And so that's why in ES6, something called promises were introduced. And with promises, we can avoid all of this callback hell here and have a nicer and cleaner syntax when using asynchronous JavaScript like we have here in this example. Okay, and so in the next lecture, we are actually going to look at promises, which is one of the ES6 features that we didn't really talk about in the last section where we talked about ES6 or ES 2015. Okay, so make sure that you understand the logic behind this here, that you really understand what the callback hell really means, because that's a term that you're going to find frequently when you're reading about JavaScript on the web. Okay, so I had to show you what callback hell here is, so that after that it makes sense to you why we use promises. In order to escape the so-called callback hell that I showed you in the last lecture, let's now learn about promises, which is an ES6 feature designed specifically to deal with asynchronous JavaScript. Now, before we start, what is a promise actually? Well, it's a complex topic and it's easier to understand in practice, but in simple terms, a promise is an object that keeps track about whether a certain event has happened already or not. And if it did happen, then the promise determines what happens next. And with events here, I mean an asynchronous event, like a timer finishing or data coming back from an AJAX call, okay? So, a promise kind of implements the concept of a future value that we're expecting. It's like us saying, hey, get me some data from the server in the background. And the promise then promises us to get that data, so we can handle it in the future, okay? Does that make sense? Now, since we're dealing with time-sensitive code now, a promise can have different states. So before the event has happened, the promise is pending. Then, after the event has happened, the promise is called settled or resolved, which is the same thing, okay? Now, when the promise was actually successful, which means that the result is available, then the promise is fulfilled. But if there was an error, then the promise is rejected. Simple as that. And this is actually important to know, because we will then be able to handle these two different situations in our code. Now, in more practical terms, we can produce and consume promises. So when we produce a promise, we create a new promise and send a result using that promise. Then when we consume it, we can use callback functions for fulfillment and for rejection of our promise. So let's now produce promises in order to recreate the example that we built in the last lecture and then consume those promises. And again, let's start by cleaning up here our code from the last lecture by simply commenting it out. So with promises, just like every other object type, we use the new keyword. So we say new promise, and then into that promise, we pass in a function called the executor, which is a function that will be immediately called once the promise is created. Okay, so let's just add that here as well, without actually for now adding any code. So again, an arrow function here. And so that's our promise. And of course, let's also assign this promise here to a variable. So const get IDs, okay? And that's because we're recreating the example that we had up here, okay? And so basically this first promise here will be responsible for doing that first part here with the first timer. So basically where we get these 4 IDs here from the server with this fake AJAX call here, okay? But now getting back to our promise here and this callback function that we pass into the promise, remember that this one here is called the executor function. And this function here itself actually takes in 2 arguments. which are the callback functions resolve and reject. So resolve and reject. And that's because this executor function here is used to inform the promise whether the event it is handling was successful or not. And if it was successful, we're going to call the resolve function, and if not, we call the reject function. So remember that we had these two states here: resolve if the promise was successful, and reject if the promise was not successful. So if you don't have any result. And in that case, we can call the reject function. And I'm going to show you how we use these functions here inside our promise in a second. But for now, let's put some asynchronous task here in the executor function, because that is usually what happens in a promise. So something like an AJAX call, or in this case, a setTimeout function. So again, to fake the AJAX call, so basically the call to a server to get some data, okay? So again, we're going to use setTimeout. With a callback function after 1 second, okay? Or after 1.5 seconds, that gives us a bit more time to see the result. Now, when this timer finishes here after 1.5 seconds, we want to return the data with some of the fake IDs, just like we did before. And so now it's actually time to call that resolve function. And remember that we call resolve in case that the event was successful. So calling the resolve function here will basically mark the promise as fulfilled, so as successful, right? And that is exactly what we want here. Okay, so let's call the resolve function here. Resolve. Now that function actually takes an argument here, which is for the result of the promise. And so this is basically how we return our result from the promise if it was successful. And what do we want to return here? That's right, that's just this array of these IDs. So let me just copy it from up here and put it down here. All right. So again, what we do here is that after this timer finishes after 1.5 seconds, we say that the promise is successful and that we want to return this data here. And that's why we used the resolve function. And since setTimeout is impossible to fail, so this timer will always finish, there's no way it is not going to finish, and so we don't need to call the reject function in this case. But we would need it in some other cases, like when we are dealing with data coming back from a server, where there can happen all kinds of errors. But in this case, we don't need to call the reject function ever. All we do here is to call the resolve function, which marks the promise as fulfilled and returns this data here. All right, and so we produced our very first, very simple promise here, which is stored now in this getIDs variable. Okay, and so now it is actually time that we consume these promises. And in order to do that, we can use two methods on all of the promise objects. And these methods are the then and the catch methods. Okay, so all of the promise objects here inherit these two methods. And so we can now go ahead and use them. So getIDs dot then. And this then method allows us to add an event handler for the case that the promise is fulfilled. So which means that there is a result. So now all we have to do here is to pass in a callback function, which will handle what we do in case the promise was successful, which will actually always be the case here in this promise, right? So as I mentioned before, this cannot fail, and so it will always be successful, and so we can always call the then method on our promise. So let's add a callback function here, and this callback here actually can take an argument. And I'm going to explain to you in a second how this works. Okay, so I'm simply calling this one here IDs, and then an arrow function again, and then just like this. So here's the function body. Now this argument here that we pass into our callback function, which is this entire thing here, right? So this argument here will be the result of the successful promise. So in this case, it will be this entire array. Okay, and so let's now log this one to the console. So console.log IDs. And that's actually it already. So let's check it out and wait for it here. And here we go. So after 1.5 seconds again, it then printed these 4 IDs in this array here to our console. So let's recap what happened here. So we created this promise here with this executor function in it. Then inside that function, we usually have some asynchronous code, which is in this case here our set timeout, which after 1.5 seconds returns this data here in case it is successful. And that's why we use the resolve function. And the set timeout function will always be successful. And so all we need to do is to simply always use the resolve function here and then pass in the data that we want to return from the successful promise. So from the fulfilled promise. And we can then handle that successful, so that fulfilled state down here with the then methods that is available on all our promise objects. All right. So we have our promise object, and then on it, we use the then methods, which is used to handle the fulfilled promise. And into this then method, we pass in a callback function, which will always have as an argument the result of the successful promise. And that's why if we use console log of the IDs, we will basically console log this array here. Okay, does that make sense? Now, as I mentioned, we also have access to another method, which is the catch method, which allows us to add a handler for the case that the promise gets rejected, so that an error happened. So let's try that one as well. And so I'm going to chain these here in different lines. So just like this. And finally, a catch. And here we usually call the argument of the callback function the error and then we can log this error to the console. Okay, so again, right now it's impossible that this catch here is actually called because this promise here is impossible to fail. So we never called this reject callback function in here. But just to try it, let me actually use reject here instead of resolve. Just so you see what happens here. And so you see the result is actually the same because we still return this data here, but this time as an error basically. So let's say we didn't have this catch here, and so now it shouldn't have any result. Okay, and so now we actually get this error here. Okay, but right now since we're actually catching this error here, and we can also instead say something else here, just say error, and then let's try it out again. And so now it says we have an error. And again, we have an error because by using this reject function here, we basically mark this promise as rejected. And so therefore JavaScript assumes that there was an error. And so this part here is the method that gets called. Okay, but now let's put it back, of course, to resolve, because our promise is always successful. Okay, so now we translated this first part here of our previous example, and now let's write the two promises to handle the part where we get a recipe based on an ID, and then where we get another recipe based on the same publisher like we did here in this part. Okay, so let's now add these two promises, and then we can put it all together down here when we consume our promises. Okay, so let's remember how this worked up here. So we passed in an ID into the callback function of this timer, which came from the recipe IDs that we got from the first step. And so let's do something similar here. Okay, and so what we're going to do is to actually create a function which receives this ID and which will then return a promise. So let's say const get recipe, which will be a function that receives the recipe ID, and with this function body here. So again, an arrow function expression here with the new ES6 syntax. Then in here, we can return our new promise. So we return and we say new promise, just like we did up here, right? And now we need to do our executor function. And this part here is always the same. We always say resolve reject, and then pass in the function body. Okay, and now what happens inside of this promise is actually pretty similar to what we have in here. So let's just get it from this part. Okay, but instead here, of course, of the console log, we will resolve this value that we have here.